All right, let's continue today with our Croof project, which is a really simple language that we can use to generate math proofs. It's like some kind of Wolfram Alpha, but ordered from Wish, obviously. So let's get like a short recap of what this language is capable of. So we can do some defines, like defining some functions, defining rules and stuff like that, and then we can ask the interpreter to evaluate like an expression, right? And right now, obviously, it's still in development. I still have other ideas of how to implement the defines because, you know, in math you have other operations other than just implies. We can have equivalence and all sorts of things. So we might think about those as well. But for now, I'm happy with what we have. And yeah, we are able to evaluate like really simple expressions. So if we run this thing, let's see like an example of what it does, and then we'll go through the syntax a bit. So you can see that we ask here to evaluate the function call on a value of 0, and it shows us step by step what it does and also the response, right? It shows us each step and then the definition that it used, right? So for instance, here it's gonna use the fact that something plus 0 is equal to something, right? And it gives us this, and then it uses the first step basically to evaluate the function in 0. And now we have even more complicated questions, and the last one is something that you know, right now our language doesn't know how to add numbers. That's kind of fair, but we'll try to get it to get the response as short as possible. So that's the idea. We want it to generate all the possible paths and give us the shortest answer basically. And in this case, it just happens that this thing evaluates to 1 plus 2. You know, we don't know how to add 1 plus 2 at this point, but maybe in the future we can. So yeah. So the syntax is pretty straightforward. You're able to define sets, right? Again, in the future we might have infinite sets, and then as someone suggested, you might even be able to define sets like A is in N, and N is gonna be a predefined set, like for instance natural numbers, so 0, 1, 2, 3 and so on, but it's an infinite set. And maybe you can even have conditions like A is less than 5, and that's how you define this set, like it's an alternative. So again, we might be able to do things like this, but for now you just define a set, you use symbols, then you can define functions. Right now we don't have any type checking, so just defining functions doesn't really help, but defining rules like this, yeah, I mean, they do help. But again, we don't have type checking yet, so it's mostly just pattern matching the expression. And yeah, I mean, it is what it is. You have the definition of the variables, and ideally we would use type checking to check that, you know, in this expression it makes sense that A and B are from M, you know. And yeah, because we might have in the future multiple sets, so some formulas might work on some sets but not other sets. So yeah, that's kind of it with the definitions. You can also have definitions like this where you just define the function, and yeah, then the evaluate, you just ask it to evaluate some expressions. So today I was thinking that we have this kind of suck functions, which is like successor, and I was thinking of trying to add some kind of formula that would help us to define numbers easily, like in an easier way. So that is usually something like successor of A is equal to successor of a plus successor of 0, am I right? Or something like that. So maybe even like this. And obviously it's for all a's, we have this thing. Or maybe I can even make it the other way around for now. And you can see that in this case, we actually have this as a rule here. So my hope would be that we find this as a pattern match, right? And we replace a with a 1, and then this thing becomes successor of 1, right? So this would turn into successor of 1. And in the end, it's successor of 2, so it's going to be 3, because we have this definition here. So we would be able to say that 1 plus 2 is 3, right, in the end. But we have to make sure that we evaluate this thing correctly. So if I run this thing now, it's still gonna... interesting. It failed because maybe it tried what? I'm not sure what it tried. Let's just remove all of this and see what it does with the last one. Nothing really. I'm kind of wondering where it failed though, but that's something that I would like to somehow implement. Maybe just remove all of these, keep just that. And if we go to the main file, maybe I guess it's no longer main, it's called solver because I try to split them into different files. I guess we could also try to look a bit into this file because it has some interesting things. So I still kept the functions from the previous sessions, like make mapping, which is supposed to take two expressions, right? Like something like a reference and then an expression. And then we want to make mappings from the expression to the reference. So for instance, I guess the easiest way to see that is here with a variable and a number. So if the reference has a variable and this thing is a number, so is that something that we have inside of test Croof? I guess we don't. I guess here we have operators. So we are on the case of operator and operator. And then we try to make mapping on the left hand side and on the right hand side. And when we do that, left hand side and right hand side are going to be both functions. So they are both functions, right? This and this and this and this. So here is just going to replace them, I guess. So successor of A is going to become successor of 1, which, makes sense. Even though I would implement it a bit more fancier, like in the future, maybe we'll see. Then we have this function called apply mapping, which gives us basically the right hand side of this equality, right? It also gives us the mapping, so what we want to replace with what, and we output the substitution. So basically we have this as the input. We know that we have to replace A with 1, so we have to build up this expression but with 1 instead of an A. So that this would be what this function has to do. right? So for instance, if we try to find the exact case, so that would be solution kind is a function, I would assume. So it's a name. Yeah, like we just replace it with the value from the mapping. So not that interesting anyway. And then we have this solver substitute, which is kind of a new function. It's a bit more tricky. So it has as an input an expression, a statement that we are trying to apply. So for instance, let's say this is our expression and this is the statement that we are trying to apply, right? Then we have a substitution and an iterator. And the idea here is initially these two variables are going to be the same. They're going to point the same place in memory, but substitution is going to be the root of the expression tree of the AST, and iterator is just going to iterate the expression. That's mainly because we want at the end of the execution to append the substitution into an array, and we don't want to lose the reference to the beginning of that expression. If you ever used linked lists, you might think of this as being the first node and this being the node that you are, doing something on. You always need a reference to the first node because you don't want to lose the reference to the list, basically. So we have to keep a reference to the first, like to the main expression, right? And with iterator, we are gonna do some changes on the expression itself. And then this mapping here, it's mainly just so we don't allocate mapping every time. So the idea of this function is it's gonna check if you can apply the statement directly on the expression. If you can, that's good. We append that as an option. Then it's going to look on the left hand side. If you have an operator, it's gonna look, can I apply it on this? Maybe here you can actually apply something. It's this one. So it's gonna say, okay, I can apply this, but on the left hand side. So for instance, here if we scroll down to expression being an operator, it can go so expression is an operator. I guess reference doesn't really care that much. Really, I don't have the okay, this one. So it's if the expression is an operator, then I can even go and try to substitute the left hand side of this thing, right? So I can actually go ahead and try to apply it on this. That's kind of the idea. So you can go like depth first search basically on each part of the expression. So that was my idea with this function. And then when we do solve DFS, we are basically just going to generate all the substitutions, and then we are going to just iterate all the substitutions. So it's like we have an expression and we want to generate all the possible cases that you can reach using all of these statements. So well, you can just use this one and you are gonna reach something different. You can use, I don't know, this one and you're gonna reach something, or even this one and maybe even this one. So that's the idea. We generate all the neighbors for the DFS algorithm. And if you visited one of these, or I guess if you haven't visited one, we visit it, right? We go into that node with DFS. So that's kind of the idea of this algorithm. Maybe to try and debug why this one doesn't work, I might have to print the substitution here, kind of trying to see what happened. So what I can do is expression printf, and we have we have something called expression, which is the initial state. So expression is the initial state. Then let's say we just printf an arrow, so we get the following thing, and then printf the substitution, and then I guess we can just printf a new line. So let's try to rerun this thing. So it tries to substitute it like this using, I mean, we can even say here printf open parenthesis and then statement printf statement, and then printf and then the new line. So it's basically we reach this thing using this formula, right? So it uses that twice. It doesn't reach anything special. Okay. But you can see it exits with non-zero exit code. So that means that it failed somewhere to do something. Which is interesting. Maybe I can just try to print a statement here and see where it failed. Printf, then new line. Like trying to see which statement made it fail. So obviously it's the one that I just added, right? And because of that, if I do here printf okay, we should see that we don't get an okay for the last one, right? That's what I imagine. Okay, so why is that statement wrong? Why is it wrong? That's curious. Let's try to go into it. So basically the expression is gonna be I can even show the expression, right? I can do something like this. Oops. And honestly, I'm just gonna do this as well. So we are basically trying to convert the expression into something. I'm gonna do dot dot because we don't really know what that is gonna be using this statement, right? So that's the idea. So we are trying to convert this thing into something using this. Okay, so let's look into solver substitute, and we have an expression that is an operator. Obviously that's the expression, and the statement is also an operator, so that's that. So we should look for the operator and operator case. Okay, so this one. All right, so we have operator twice. All right, so if the operator is the same, which is the same, we have plus and plus, we clear the mapping and we try to make mapping. So we try to make mapping on the plus operator. Okay, interesting. Which, I mean, it shouldn't work because 1 is not equal to 0. That's the first case that I see is kind of wrong. So probably something wrong with make mapping. Like it should fail. So if I do printf here, let's do an OK. We should see that for the last one it should fail, but it doesn't. So that's kind of wrong, right? So let's go into make mapping and find the case with operator and operator, because that's that. So we can see that it calls to make mapping on the left hand side and make mapping on the right hand side. So it's gonna try to make mapping successor of 1 with successor of 0 and successor of 0 with successor of A. The second one should be okay, I don't see any issues, but the first one is clearly wrong. So if we go into make mapping, like recursively again, we should have function and function. Here we just create the mapping without checking anything, which I think it's not the best idea. I think that if the arguments count is 0, then it's fine. So if we have just a plain variable, it's fine to do this. Not completely sure, but if we have more than one like argument, so if it's a function call, we should do something different, which is checking if the arguments are the same. So they have to be exactly the same. Not sure. It's like, yeah. So let's go back, because I know I have something like that. So yeah, this kind of looks like it. So I would have to do something like this, I think. So I guess we could just try to copy paste this if statement. Kind of, you know. So that would be the if case, and then we have the else case. And on the else case, we should check reference function value with expression function value. We check that they are equal. Okay, if they are equal and the number of arguments is the same, we assume that we can substitute. Then we have to iterate all the arguments. So we get the reference arguments and the expression arguments. If they are equal, then we have false. And if we can substitute, that's when we should create this thing. Right, so if we can substitute, then we do that. Here I guess I have to return true. On the else case, I have to return false, but in this case we also return true, I guess. Yeah, I mean, it's really ugly. I would have to think of a better way to do this, but let's see now what happens. So we get 1 plus 2 and so on. Let's see where it applies successor of successor. But why doesn't it apply successor of 0 plus successor of 1? It's really strange. So we had this one with operator, operator. Let's say that we just remove all of these and we only keep the first one. So it should try to apply this. Why don't I see it here? Maybe I'm just blind and I don't see it, but it's clearly not there, right? It just tries this one, but never comes back to successor of 0 plus successor of 1. That's pretty weird. So for each statement, because it's not like we change the expression itself. Like we never change the expression. So why don't I see the right statement here? Let's just say that we comment this one out. Yeah, but why don't I see this one? So what happens with expression? Oh shit, I mem copy into... No, that's fine, right? It's like previous, it's just the parent key value. It's so weird that I guess it fails, right? It fails again here when it tries to apply this one because it's number and, or I guess it's an operator again with another operator, and so we have this one which is operator, and we try to make mapping again, I guess. And this time we have the expression is a number and this thing is a function. So function and number. I would say we have to copy paste again from substitute, which is that if we have a number and a function, oh, this is function. I wanted to see function and number, but I don't have function and number. It's like, sure, if the number of arguments is 0, then you should be able to do this replacement, but otherwise you shouldn't be able to do that, I guess. Okay, nice. So we have now also, so now it iterates everything, right? So we get all the options. 0 plus 1, where is maybe 0 plus 1? This one is what I'm interested in. So let's go back to the triple dots, right? And I'm just going to copy this one back here, and instead of triple dots we are just gonna print the substitution. So let's see. So 0 plus 1 is that. I don't care. I want to see not really. I don't see it with successor of successor. Yikes. But why would that one fail? Let's think about it. So we have successor of 0, right? We have this one needs to pattern match with this one, for instance. So we have these ones are equal, right? So let's go back to operator and operator, which was here. So it's gonna make a mapping of both of them, so operator and operator. So it's gonna make mapping of left hand side and right hand side. On the left hand side we have this function, and on the right hand side we have this function. So what it's gonna do is gonna come here where we have function. The number of arguments is not 0, so it comes here, it sees that it's the same function, the same number of arguments, but the problem is can substitute. It's not really the best case here. Here what I should do is go through all the arguments, and instead of checking if they are equal, what I should in fact do is call recursively to solver make mapping. So I should do can substitute and solver make mapping, and the reference expression, oops, I mean I should still read those, but I should do solver make mapping, and I should give it the reference is a reference argument, the expression is expression argument, and mapping is mapping. So we recursively have to call to make mapping here, and we build up can substitute. And I guess I don't really care about that, and I should just return I should just return here, return can substitute. That's what I have to do. Alright, so we are trying to create substitutions for this, like this one with this one, which is gonna be 0 is equal to 0, basically the arguments. So it's coming here where we have number and number, and for the other one is gonna have the argument a with 1, so it's gonna be function and number, which is this one, and it's gonna do this. So I think, okay, this one makes it fail. It fails at 2 plus 1 is 1 plus 2. But why? Or I guess it fails after. So let's put this one here again, triple dots. Let's see where it actually failed. So it failed here. Interesting. Curious, why did it fail? So successor of 0 plus successor of A. So it's gonna do solver substitute. It comes here with this one, printf okay, because it should be okay, right? It's okay, nice. Then I guess let's see, shit, what do I want to see here? So the right hand side is basically this expression. So if I do printf, no, expression printf statement equality right hand side, I should see successor of successor. Then maybe for unsigned int k is 0, k is less than mapping count, k plus plus. Mapping has pairs, so pair tp, I guess let's make it a pointer. ds dynamic array get ref, and we are going to pass mapping k and void pointer p. Let's do key and value. So I'm gonna do expression printf p key p value. So I'm gonna do printf, and here we are basically apply. Let's just say apply. Then printf, maybe a space, I don't know. Here I'm gonna do printf like this, and printf a comma, just because. Okay, so if we do this, we should see that we apply in this expression, a becomes 1. That's huge. Like, that's exactly what we expected, right? So what happens then in apply mapping? Maybe there's something wrong in apply mapping. So we know that the solution is a function. Wait. No, I'm kind of curious what iter is, but I'm kind of curious what iter is. Printf a new line and maybe expression printf iter. I'm not exactly sure what iter should be in this case. The fuck? Whatever. Probably it's like empty expression or something, and that's why it was we thought it's an like whatever, doesn't matter. So in any case, we want to apply a becomes 1, right? That's the idea. So let's check out apply mapping. In apply mapping, obviously the solution is this thing, right? Makes sense, makes complete sense, but I'm not sure why iter is that. It's kind of stupid. Anyway, or like substitution. I don't fucking know. It's like here we define this as being 0, right? And we pass it like this. So it's nothing basically inside of the thing. So it's nothing inside of this iterator. So when we are trying to apply the mapping, we see that the solution kind is a name because that's what it is. It's successor of A, right? We are trying to find mapping for the solution, which kind of doesn't make sense because it's not gonna find it. The fuck is wrong with this? Maybe I didn't do. So we have operator and operator. Yeah, maybe something wrong with apply mapping. So in apply mapping, what do we want to do? If we have a set, right? We initialize this thing, substitution set items, makes sense. We go through each item and then we apply solver apply mapping, complete sense. If we have a name, I guess here it depends if you have a variable or a function call again. So if solution dot function dot args dot count is equal to 0, I think it makes sense to do this part. So we are searching for this variable inside of the mappings and we just replace it, right? Otherwise, we want to say that the substitution kind is a function, so it's kind name. Maybe we want substitution function value to be the solution function value, right? We just set it. Then we have to initialize the args, probably. So if it has arguments. But no, not, yeah, it should be okay. It should be okay. So we initialize the function args with expression t, and then we have to do a for loop, over the arguments basically. So solution function args count, we have argument I, function args, we take the argument, and then we try to apply mapping on the argument, and we append to function args. We apply the item. I think that's that. If we have a number, then we just replace it. If we what the fuck is kind function? Oh, I'm stupid. Yeah, I should have done it here. Yeah, like name is for the sets. Let me just go back. So it's here for the function, right? Basically, if the number of arguments is zero, we just treat it as a variable and we try to make the substitution. Otherwise, if we have arguments, then we try to substitute each argument. Then for the right hand side, for the operator, we are just doing it on the right hand side and left hand side, pretty simple. And for the parentheses, we do it in the inner expression. Let's see if this helps. Response successor, that's funny as hell. So this one is interesting. And here it actually applies it, so that's cool. But the problem is something is wrong. So substitution function value gets done correctly. So printf, if you know the trick with printing strings, then you can use something like this: substitution function value len function value str. So I think we should see that it finds it, but maybe it's you know, printed somewhere randomly. Okay, but then what went wrong here? So we just iterate all the arguments. We take the argument solution function arg_i, we create an item, and here we append it into substitution function args, which was initialized. Expression printf item. Let me just printf something before and something after, just so we can identify this. It gives me a 1. And then suk. Fuck. One makes sense because it's the, if you think about it, it's the last one. But then why? Why doesn't it have the right arguments? The fuck? Let me just remove this thing because it's kind of too much. But yeah, it's still cool that we see all of these things. Like this one, apply a is equal to 2 and b is equal to 1 on this thing. That's so cool. Anyway, let's stop being So this one like that. I mean, on this thing, you should kind of be able to apply this as well, but yeah, it is what it is. But it's kind of interesting, why does it do that? So we should have something like this. And why is it suk? Only suk. So our substitute. So let's go back to substitute. So we have, as we already kind of know, we have the operators, obviously. Let me just remove this stuff as well, because we see that it's fine. So we try mapping, or I guess we make mapping, which works. Right, we had that a is equal to 1. Not really that one. I'm not sure where it was, but I remember we had a is equal to 1. I can even search. Apply a is equal to 1 on suk a, right? So that was the idea here. So this one should be fine. Maybe what's worth checking is if the iter is actually good. So expression printf iter, and maybe a printf like arrow, and then printf a new line. So I would expect to not see the right result here. Right, like here. Iter is not correct. Kind of sucks, not gonna lie. Kind of sucks. So I wonder why. Right, because here we just pass something from the stack. So there's nothing really that we need to do there. Okay. So the mapping, which is just the array. So we already have a is equal to 1 in that thing. That's cool. So let's double check apply mapping. Right, apply mapping obviously is gonna go in the function one. So function, number of arguments is not 0, so it goes here. We say substitution kind, shit, it's a function. Probably someone was yelling that, but sorry about it. So we get this thing. Where is now a is equal to 1? Yo, we actually get this shit. Apply on this thing, we apply a is equal to 1, and we get successor of 1. Now I'm curious if we ever get to do something on this one. Not sure. Maybe because I removed the prints. Right, yeah, I removed the prints. Let me just move this stuff somewhere here, maybe. So here we had triple dots. So again, I'm curious if we have successor of 1. Okay, so we are trying to apply something on it, but we never get the response. So let's see why is that. Why is that? So we go into solver substitute. We basically have expression is a function. The statement is also a function, right? Like the statement that we're trying to substitute with. So we have function and function. Arguments are not 0. And here we are trying to do equals. Here we are trying to do equals, but it's not gonna work. It's not really gonna work. Right, because what's gonna happen here is it's gonna check, okay, is this argument equal to this argument? No, it's not 0. This thing is not 0. It's not 1, it's not 2, it's not 3. It's just another function. So obviously they are not equal. So what we have to do is something similar to what we did with operator, which is that if we cannot directly match, it wasn't this here. Solver apply mapping. Yeah, I mean it was here. The fuck? I guess it wasn't with operator and operator, it was with function and operator. So if we cannot directly match it, we try to match it with the left hand side, for instance. So what we can do here is, if we can substitute it, that's cool. We substitute, but otherwise, even if the functions are not equal, we can do that. So I would do it maybe right here. What we can do is iterate But here, what if I was looking not at the reference but at expression? I think looking at expression makes more sense. Or does it? I think it does more sense. Here it just happened to be that. Okay. Not exactly sure. Yeah, let's keep it reference. Whatever. So what I'm gonna do is, we need this kind of for statement, similar. We put it here for expression function arguments. We need to take the expression argument, right? We need to take the expression argument. Okay. We also, shit. So I just want to so in this case, what I did was I set the kind to be an operator. I set the operator's value to be, the operator, and I also set the left-hand side to be the expression left-hand side. but for the right hand side I set nothing basically. And what I did was recursively call to substitute on the right hand side expression, because that's what's null. Statement stays the same, substitution stays the same because it's the root, and iter advances on the same branch like the expression. So I would have to do something similar here, which is basically build expression. I have to send in the argument here. I have to send in this, and iterator is gonna be that. So I have to kind of build this new substitution. Let's just copy paste this thing. Not sure if I want to do it outside of the for loop or inside. So expression kind function. Expression function value has to be the same, so it's the same function. Then we need to initialize the, where do I have like some initializing? Don't really have one, so let's just do it ourselves. So ds dynamically copy. I think I can just copy. Yeah, I think I can just copy it. So I'm gonna copy from expression function dot args into iter function dot args. Problem is that it's kind of difficult to do it for each one. Yeah, it shouldn't matter. Let's actually let's copy this inside of the for loop. So I'm just gonna copy it each time in the iterator, and you can see here I was setting it to null. Doesn't matter, it's already copied anyways, so that's fine. And we also have expression arg, which comes from expression, but now I also need iterator arg, so the argument from the iterator. God damn, this shit, it's getting out of hand. Come on, it's so messy. And then we have to call substitute. But I don't know if I want to do try. Like, I don't know if I want it to fail. Like, I don't want to fail the entire for loop. That's what I mean. Unless it's like a memory error or something, but not sure. I don't think this fails that easily. We'll see. Like, yeah, obviously it's gonna make sense. Anyway, so this thing we are trying to substitute into expression arg. Hopefully it makes sense, right? We are trying to substitute into this argument with the statement. The substitution is just the root, so we don't change it, and this should also follow the expression. Substitution stays the same, mapping stays the same. Okay, so we actually get successor 1 as the response, although that's not what I wanted to see, because it can go further. It can go on this case. Let's just see. Sorry, expression printf, expression arg. Let's just see the expression arg. I think, I guess it depends. Yeah, shit. What do I expect to see and where, basically? So successor 1, we get successor of 1 and then 1. But why? Yeah, 1, because we have 1 here. But this one should be good. The fuck? So just like we said here, apply blah blah, let's try to visualize some apply there as well. So here, for instance, if we have function and function, I mean, we already have substitute here. But how can we tell in an easier way? Let's just go to test Croof, and let's say here successor of 0, and let's just remove everything else. Basically, we don't really care. So we have this thing and we are trying to use this, right? That's what I'm trying to say here. But I would like to see more of this thing with apply. But we don't have make mapping here because obviously it doesn't make sense, I guess. So in this case, solver substitute, I guess we don't append anything. Should we do? No, we shouldn't append anything. Yeah. But obviously it should come in this case. Because it tries this stuff. But obviously we don't have any response for it. When I did this one, it was successor 0. That's basically the expression arg. So how can I print f? Can I do something like this? Apply statement equality right hand side. try to get this thing, something like that. I don't know. Does that help? Apply 1, successor 0. That's the iter. Should be good. So basically here we are gonna get that expression arg is successor 0 and substitution is whatever successor 0 is equal to 1. So we have function and function, right? So it should get that the expressions are equal. So shouldn't it get here that the expressions are equal? Like apply 1 is equal to 1 here, and that's good. Yeah, that's actually good. Substitution, so it applies the it adds the substitution, right? We don't even need this one anymore. Oops. Oh wait, was it a big fail? I think so, yeah. So here it's whatever expression. Let's go back to using this one. So here, so successor goes into this, and it should replace successor 0 with 1. Okay, interesting. So it should replace successor 0 with 1. That's what I see, right? Am I stupid? No, what the fuck? Wait, why is substitution still successor 0? Wait. Because here I said iter is statement equality right hand side. Wait, what the fuck? So here it goes like this, iter, copy the function, copy the arguments, iter arg, we take it from the arguments. So expression is successor 0, statement is successor 0. So it also goes into this function is function. It checks these two things, they are the same, that's probably gonna happen, these are gonna happen, they are all equal. So why doesn't it do this and then append the substitution? That's weird. So substitution, why is it still the same? This should be successor 1. Um, expression printf, I don't know, 0 successor 0. What the actual fuck? Successor 1. So that's the substitution that was appended. What the actual fuck? Like expression substitution statement. Why isn't it successor 1 here as well? That's really strange, because that's what it should be. What the fuck? This is crazy. I mean, some debugging later probably, I guess. Probably will take a short break and see if I can figure it out. Why the fuck there's... I mean, maybe it's just that I use the memory stupidly, like, you know, the usual C problems. Maybe if I run Valgrind on it... Oh, there's no errors, really? Shit. Yeah, so I mean, you know, I'll just take a short break and see if I can figure it out on my own. So yeah, catch you later. Right, so don't actually ask me how this was fixed. The thing is, no idea. I mean, it's just C, and it's already extremely complicated. So yeah, memory safety, it's, you know, out the window. Basically, what I thought about was, well, if you can substitute, right, you are just gonna do this part, and otherwise if you cannot substitute, so if I guess if you can substitute, you're gonna substitute the function call to whatever variable or whatnot. But if you cannot substitute that function call, you try to substitute the arguments. No idea why it's not working if I try to use both. I would assume here we change ether, then we change ether here as well, and because it's a pointer, it changes it inside of the array, which is kind of crazy. So yeah, I mean, you know, obviously if we get this thing to work kind of decent, you know, I was kind of thinking about trying to use some kind of parser like Antler, and maybe porting this in some other language like Go. But you know, as long as it's still working, it's fine. So let's go back to Croof. Let's add back our things, and let's try to run it with 0 plus 1. And I mean, that's fucking crazy. We can actually evaluate 1 plus 2. So if we try to add successor 0 plus successor 1, first it's going to apply this formula, which is that successor of 0 plus successor of a is successor of a, so it's going to apply that. Then it's going to apply the fact that successor of 1 is 2, so we get successor of 2, and then successor of 2 is 3. So yeah, I mean, this is really cool. So let's go back here. Let's see, because I've deleted some evaluations. Let's see if these still work. Hopefully they still work. And yeah, they still work. And now instead of 1 plus 2, which is what we were getting before, we actually get 3 as the result. I think this is pretty cool, I'm not gonna lie. Okay, I think something else that I was thinking about was, you know, usually some formulas work like this one with the parentheses. So a plus b then plus c is this, a plus parentheses b plus c. but this one also works the other way around. So that's why I've written it twice. And that's why I was thinking about using equivalence like this, just so you don't have to write things twice, but doesn't matter. But another one which I found kind of tricky was this one. And this one is also true. However, the problem is if we use it like this, then it's gonna generate an infinite expression because it's gonna keep applying it. It's gonna see that it's not visited yet, and it's just gonna add +0, +0, +0, and so on, right? So that's the main problem. Now, one solution that I was thinking about, so let's just see what happens, right? So if I run it like this, you can see that it keeps adding +0, I would guess. But I don't know why it's not printing it. Anyways, it doesn't matter. The idea is it keeps adding +0s, right? No, it doesn't look like that. I don't know why it's not, why we don't have a +0 here, but doesn't matter. Or maybe it doesn't work. That's kind of weird though. Again, it's because of C. Sucks to suck. So yeah, like whatever, and what I was thinking was, well, we could allow expressions like this which increase our formula, but what we would have to do is to go here, take the expression degree, and try to maybe say something like not allowing an expression to exceed a certain amount, like a degree. And we would have a maximum degree which we allow. That could make sense. But yeah, like for today, that's what I was trying to achieve, being able to evaluate this one to be 3, which is actually pretty cool. So let's go back to Croof. Can we maybe have an even more complicated one? I'm not sure if we have that number though. Okay, maybe we don't have enough numbers. Do we? Or, I have to add parentheses. Interesting. I mean, we have 4, so why wouldn't it work with 4? So first step was to change these. Interesting. Then I did something with parentheses. I mean, come on, man. Do something good. What the fuck? Here it got 0 plus 0. But I don't see anywhere the important formula. Okay, let's actually see and generate all of them because I'm curious. So here, this one's interesting because it should work. So even if it doesn't work here, it should work at least on the parentheses. So why didn't it work? Let's take a look at the expressions. So in substitute, we basically have two operators, right? Operators like this one and this big one. Then we apply mapping. We make mapping. We try to make mapping, and we have operator. Operator operator. So it should compare this one with this one, and then parentheses with function. Okay, so first one is pretty clear, it's function and function, but both of them are equal. So it should go on can substitute because it's suck0 and suck0. And the other one is function and parentheses. If the reference is a function, so here it's a function, and we have a parenthesis, so if it's a function, it has an argument, and we have a parenthesis. It's an interesting problem. Because it's kind of hard to replace this thing with suck a. Like you'd have to, yeah, it's kind of hard. This thing with suck a, like we don't have any formulas like this. Suck0 plus suck1. I mean, yeah, we don't have. So that's kind of rough. What would work then? Well, if we could somehow match this with this. So let's say we go back to solver substitute and we have operator with operator. Right, we have operator and operator. Well, we could try to do this one. So if we have operator and operator, we should be able to try and make either be an operator, right? Wait. Yes. Then copy the operator value, copy the left hand side as the left hand side, allocate the right hand side, and then we try to substitute into right hand side. Why not? Let's see what happened at this point. So I would be curious to see something like suck0 plus suck0 plus suck1. Where can I find something like that? I mean, yeah, no, this one's kind of hard. Damn, this shit's long as fuck. Okay, maybe I can search for it. So, nope. Do I really have to use parentheses? Yes. So suck0 plus parentheses suck. I'm gonna just search for fuck. Do I have to set plus with? Oh yeah. So actually this one is the good one, right? Suck0. Huh. But that's what I would think here. I'd make operator to be the value, left hand side stays left hand side, then we allocate this shit and we try to substitute right hand side with the right hand side. Thing is, right hand side is a parenthesis, right? Right hand side is a parenthesis. So we have to look at parentheses as well. So the expression is a parenthesis and the reference is an expression. That's the important part. Function, we don't have function. Yes, we don't have operator and parenthesis. So let's try to add that. Operator and operator and parenthesis. So if we have operator on one side and parentheses on the other side, we don't care if they are equal or whatnot. What we care about is trying to match the expression inside. So it's gonna stay a parenthesis, pattern dot export, I guess. It's gonna get allocated, right? It's gonna get allocated, and then we have to say that we try to evaluate parent expression with parent expression, and then this stuff does make sense. I think that's what we have to do. Oh shit. Okay. Let's only leave this one. It kind of shits itself because there's nothing here, as you can see. Not really sure why there's nothing there. So we have parentheses. Basically go inside of the parentheses and try to do a substitute. So what we would get here is expression with expression. So we would get expression plus expression, and the other one is also an expression. So we are on the operator case. Maybe this should be only if else, I guess. I don't know. But yeah, it doesn't make sense to do it only on the else case. Yeah, you cannot do it only on the else case because you want to do it also here. But we should get some. Let me just yes panic just to see if we get here. Okay, we do. That's nice. But for instance, what do we get? Maybe here expression printf. Yes. Suck 0 plus. So why does it shit itself? So before that, iter should be just nothing, just parentheses, because we don't have anything inside. But yeah, it's kind of like an else here because what happens probably is it does this thing and then somehow it does also this thing and it modifies this somehow, I don't know. But if I do it on the else case, it's not gonna do it here. Fuck. So basically it's gonna do solver substitute. We have that 0 plus 1 here, right? 0 plus 1, and here it's gonna come here because we have two pluses like that, so, or whatever, something like that. And really not sure. Do I have to clear the mapping when I go here? Nope. I mean, doesn't matter. That's what I meant. But what the fuck? What the fuck? So should go in that like inside of this expression, and here it should give me the substitution. So maybe I can just expression printf substitution. Have a new line just to see it. Wait, what? I mean, interesting. Maybe it could be that it tries to do substitution here with a plus 0. It doesn't work, so maybe the if statement is like false, right? So it goes and tries to do this one, which is basically trying to apply a plus 0 on suk1. So reference is plus, or I guess operator, and the expression is function that doesn't really exist. So it returns result. Do I have to return defer ds error on the other case? So if you cannot substitute? I guess no. Yeah, like it's weird. This one shouldn't really return like failure. This one shouldn't really fail as a function. Like even if it fails, it shouldn't matter. That's what I mean. Oh shit. Fucking this fucking shit, dude. I'm really not sure what to do in this case. Hmm. But yeah, what I meant is shouldn't really fail it if it fails, right? Like we don't really care because some paths will fail for sure, but that shouldn't tell us that okay, this you cannot solve this expression. Doesn't matter. So I think it should be actually like void in here or something. Like we shouldn't have result. Or I mean, you know, like sure, right? You can fail like this because this is like an assert or unreachable cases. But yeah, I mean, it's more of a panic, this one. So here I can just ds panic, right? but here if you fail to substitute, maybe you shouldn't do anything. Oops. Or should I do something if you fail? Should I care? Or in here? Again, I don't think I should care that this one fails. Maybe this one is also like unreachable, because if you make mapping and it works, then you should be able to apply the mapping. Like, it doesn't make sense. It means I have a bug in the code. So maybe we don't need that. Solver substitute, this shouldn't be an error. Right, but for instance here, if I have an operator and parentheses, I should just try to substitute inside of the parentheses. That's it. It makes complete sense. Right, yeah, I mean, I should just try to substitute inside of the parentheses. Then what happens next is that I have operator and operator. First is gonna try to make mapping. It's gonna try to make a mapping, but maybe it doesn't work because, I don't know, if I look at cat, it might not be able to, I don't know, map this one to this one or something. So it's gonna try to replace this with this, and that doesn't do anything because it's a operator with a function, so it doesn't work. So it shouldn't do anything. But what that means is iter is changed to an operator. The expression is copied. This thing is also set. It's so fucking annoying. Maybe what I want to do, let's double check. So solver substitute. Maybe what I want to do here is, but it's so weird because dynamic append, it uses mem copy. Huh. Like I need some kind of deep copy for expressions or some shit like that. It's fucking crazy. Because what might happen here is this one gets modified because of something else or some shit. So yeah, maybe I need something like, so we go to expression printf or something inside of parser, of course, parser h, and let's do something like void expression clone, source and destination or whatnot, and let's go into parser c, expression printf, and let's go ahead and implement this scheiße. So let's let ChatGPT do that. So switch, source kind, void. So expression has all of these expression set t and whatnot. So for printf, it's just clone that. Fuck. Return expression set clone. Return. Come on, man. Just pretend I have those. That's the point of ChatGPT. Come on. And that's how I like to use ChatGPT. Expression set clone. Sure. It's fucking stupid, but no, it's actually good. Easy though. I think I need to send. Do I need to send the expression, the destination expression? I was thinking if I had to send it double pointer, but I don't think so. Let's see what it's gonna do for expression name clone, for instance. Destination value is source value. And I don't think I see a problem with it. Number function. Yeah, I think it's fine. Operator as well is just allocating some shit, and parentheses, parent clone. So if we go back to solver, solver C, I think that when I append this thing to substitutions, I have to clone the substitution just so that it's not gonna so expression t s. Do I have to expression clone? No, substitution, because that's what I'm building. Maybe I have to do something like this. And you know, since it's since I use a mem copy, I think it's fine to allocate it on the stack. Okay. Expression ts. And I think it should be fine. What is it doing? Okay. And here we have function and operator. Why not? Let's just pretend that we're doing. And this one is function and parentheses. Okay, expression s. So let's try to clone it. This one is operator. Let's try to clone it. Why not? And then we have this useless stuff, and the last one is the parentheses. Again, I think I have to clone it. Oh, fuck. Yikes. I'm kind of curious what the fuck happened here. Interesting. What the fuck is this shit? But if I just kill it and then we rerun it, so it does generate that, generate visit. Oh, visit suck goes into some kind of shit. So it actually shed itself. Okay then. But why? So it tries to apply something like a plus b is equal to b plus a. Plus b is equal to b plus a. Let's try to test this function. Maybe it's something wrong with it. Expression ts is 0. Let's try to print s. Okay, looks like it's not working. Fucking ChatGPT. Come on, man. Like, it was generated with ChatGPT. Now, what can I say about it, right? Expression set clone. Like, first of all, it didn't even set the kind of the expression. So dst kind, like we should set the kind. Oh, ew. Oh, fuck. Hmm. Clone. I mean, for numbers and stuff like that, looks fine, honestly. But what was wrong with it? Case. Maybe I need to set the kind. I don't see why it being allocated on the stack would matter, to be fair. Okay, so I just forgot to set the kind. Okay, that's fine. Crazy that it was that mad. Anyway. Okay, expression, perfect. So let's take a look again at this thing. So what I was interested in, actually, I mean, we could even just try to isolate it, would be this kind of expression, right? So it goes, you can see that here. Wait, let's see it step by step. So here I don't like it. I like this one more, honestly. So this one goes into this one. Then the one with parentheses goes into the one without parentheses. So here it's fine. Why doesn't it like this one? So I would like to see something like going with this. Yeah, but I don't like that it expands too quickly. Okay, this one's not good. This one? No. This one. This one's kind of... oh! This one is the right one that I was looking for. So this one plus the parentheses, it applies something in the parentheses, right? With this formula. So we get suck0 plus suck1, right? Then we have generate for this, doesn't work, this doesn't work. Or I guess, you know, kind of does work, but we don't really care. Then this one dies. Then we have this attempt, this one, which is operator. We have an operator, and here we have a parenthesis. Operator and parenthesis. Actually, operator and parenthesis should give us something. So let's go into solver substitute, and we are looking basically for reference being a parenthesis and our expression being an expression or like operator. So expression, parentheses, and expression kind operator. Usually I put them in the order of their definition. So let me just move this one. So we have a reference is a parenthesis and we have an operator. What I would like to do in that case is to just... Here I don't know if I want to clone. Oops. Where was it? Here, I'm not sure if I want to clone this one. I don't think so. I think we only clone if we have to append it. But anyway, doesn't matter. We just kind of want to copy this thing somewhere here with the parentheses. So we know that the reference is a parenthesis and our expression is an operator. So we do expression kind operator, iterator is that, left hand side stays left hand side, right hand side is allocated. Maybe we want to also do it for the right hand side, but I don't really care for now. We allocate it, and we go in. Okay, so should this thing work? And we get a 4. Holy Croof. Let me just add all of these. Let me just delete all the printfs because oh, why not? And other ones still work. So how did it solve this one? So it did a plus b is b plus a, pretty strange. Then it moved the parentheses. Fuck. Then it opened parentheses. Interesting. Then it did a plus b is equal to b plus a. Interesting. Then it converted this thing into suck1 1. Nice. Then it did suck1. Then it did suck2. Then it did suck3 and 4. Yeah, I mean, decent, solution. It's not how I would have done it, but if it works, it works. What can I say? Right? And the last thing I would like to test, since we implemented clone because I couldn't do it otherwise, would be what would happen if I remove this if. Would it still work? I'm curious. No. So I still can do without this if. That sucks. Well, anyways, it is what it is. But now we are able to evaluate even more complex things. And I would say thing is, it doesn't matter that we only have left-hand side here. Like, it doesn't matter that we only look at the right-hand side, because it should know to switch them. So it should know to swap them and convert it from right-hand side to left-hand side. So it doesn't matter. Right, so if I do suck 0 plus suck 1 plus 0, it should still be able to solve it, right? What did it apply here? A plus 0 is equal to A. Nice. And then it swapped them for some reason. Then it opened the parentheses, then swapped them again. Yeah, maybe I can also try to find the shortest path. And then A plus B is B plus A to swap them back. And then it did suck 1 and then converted it to suck 2 and then suck 3. Nice. So yeah, like we are kind of able to evaluate these kind of things. Now sure, what would be some next steps would be to implement like infinite natural numbers, then somehow implement suck, the successor function, to be built in so that you don't have to write this. It's like defined. But maybe this rule should be done in like stdlib kind of, but like this mapping should be done automatically, right? Like that's what I would like to do. So if you have suck of a certain number, then you evaluate it to the right value, right? But yeah, it's pretty cool that we actually are able to evaluate things like this, right? So all of them seem correct to me. It shows all the steps. That's kind of cool. And as I said, I kind of feel a bit frustrated with C because it makes it really hard. Like, even though, I know C pretty well, it's kind of making things annoying. So I guess it would make sense to write this thing into a, not really better language, but trying to have better code in some sense. I mean, you can do it in C as well, but yeah. If you would have the option, obviously I would choose something else. I'd say, since I would like to try to use Antler, that I think that's available for like Java or Golang or C++. I would never use C++, but something like Go would make sense for me. I really like Go because it's extremely simple to use. Yeah, kind of sad that it doesn't work with C, but again, this, I don't know, it's a bit frustrating to use C once things go, too far and they grow too much, like with these kind of data structures. Kind of annoying. Not sure what to say, because it's gonna become, a matter of trying to add a new feature and then fix all the things that break. That's usually how it goes. I'm not gonna say that it would be different with Go. Like, the only thing that would be different is we wouldn't have memory issues. But even here, we wouldn't have memory issues if I done expression clone from the beginning. So yeah, it is what it is. So maybe we can just keep going with this implementation. Why not? See how far we can get it. Like right now, I think, got what I was expecting from the beginning. It's extremely cool. Maybe having multiple operators, not just plus. And as I said, I think next step should be implementing infinite arrays, like infinite sets, and having this successor function somehow built in. Maybe even plus is going to be built in, who knows, like operators like this for natural numbers. And then you should be able to define your own stuff for subsets. Maybe I'm also going to add being able to have a set of, I don't know, animals, like using quotes. I think that's a good idea. But once we do that, we need to actually type check stuff. So I think that's gonna be interesting, actually doing type checking. So yeah, maybe next time we'll try to implement infinite sets and have the successor function be kind of built in. So at that point we should be able to have more complex stuff. Yeah, and it's also maybe who knows, because right now I cannot say 2 plus 3, that's not a thing. All right, it doesn't know how to convert 3 is equal to suck 2, right? It doesn't know how to do this. And even if it knew 2 is successor of 1, right? Even if it knew, maybe 1 is suck of 0, maybe is that gonna help? Nope, because it's like going to convert 2 maybe into successor of 1, then what, maybe convert this into because it also doesn't know how to do the reverse. If I add the reverse, so suck a, what's gonna happen here is it's gonna reach that well, really, I thought it's gonna go insane mode and it's gonna try to go to infinite. But here it's interesting, why didn't it just replace 2 with suck 1? So generate, we have an addition, so I guess the expression is a number and the reference is a function. Maybe I have a constraint for that. So if we have the reference is a function and this thing is a number, where is it? We don't have one. So I don't have reference is function and expression is number. That's what happened. But it's like, how do we know that it's right? So I would say that in this case, if this string slice equals, so if the reference function, or no, if the statement equality dot right hand side, so the result basically dot no, I'm gonna do, so expression kind needs to be a number, right? Maybe it's gonna be expression equal, and here we have to give it the statement arrow equality dot right hand side and the expression. That's kind of, oops, the fuck, when we could replace them, right? It's like, so here we have, no, it's like, oh no, it's two numbers. So we have an operator. It's more like this one. We have an operator and then we have number and number as the right hand sides. So number and number. But I'm doing this. What? I'm appending the substitution. Fuck. Expression printf. It's weird. Right, because in this case we have 2, it's matching with 2, so it should replace it with suck1. That's strange. Reference number value. Really? They are not both numbers. Stupid. So I guess it's a reference. No, you know what happened? A reference is a number and the expression kind is an operator. So we have number and operator first. So first of all, we have number and operator. And what should happen if we have a number and operator? I guess we only replace the right hand side and try to substitute. So we make it an operator, we set the left hand side as it is, allocate, and we just go with the right hand side. Maybe. So substituting number, well, I guess 2 plus successor of 2, that's something. right? Like here, for instance, 3 plus successor of 3. Here it does 1 is equal to successor of 0. So I guess at this point we have number and operator, so it should go inside. Okay. Number and operator. Then we have reference is number and function. So function and number. Function number, we don't have function number. Function and number. So the reference kind is number. Wait. Yeah, the reference kind is number, and this one is a function. Or no. Actually, maybe. So if the expression kind is function, I guess. So we have here this number. I would like to replace it with something like successor 0, right? So we have number and function. If we have the reference is number and this thing is a function, then we kind of have to go through the arguments. We cannot do anything special. Through the arguments, we have expression arg, comes from the function of the expression. We create an expression kind function. We set that. We do dynamic array copy, whatever. Then we say iter arg, and we try to replace into expression arg. So expression arg is gonna be this one, the statement. Maybe. Let's see. I was interested in seeing something like 3 plus, oh, this one. Okay, 3 plus suck 0, 0. That's nice. 3 plus suck 0, 0. But why is it like dead? I guess there is no other formula for it. Okay, I mean, this one would be interesting, see? So it manages to do something cool, but it's like stopping. But why don't we have... Oh. So it doesn't really know how to do something with this, which is kind of annoying, maybe. Maybe I can help it with something, I guess. Let's see. So in here, maybe another formula that we can use is something like suck of A plus suck of B is suck of A plus suck of B, right? It makes sense. We move one from one to the other. Still doesn't like that. I mean, doesn't use it. Oh, this one was the closest one actually, right? So this one goes into suck 0, suck 0, and it's suck 0 plus something. But we have suck 0 plus something, don't we? Suck 0 plus something is basically this. So why didn't it find it? Let's just copy paste it just to see if it's gonna find something. Huh? It really doesn't find it? So suck 0 plus something. That's kind of weird. Oh, it's 1 plus. Okay, I know why. It's because we don't have 5. Suck 4 is equal to 5. Okay, 4 is equal to suck 3, and 5 is equal to suck 4. So we didn't have... that's fucking crazy. So now we are able to actually add numbers. Okay, that's kind of cool. I mean, that's exciting, I guess. Right, so let's see how it does it. So 2 plus 3, obviously it applies a plus b is equal b plus a. That is fucking stupid, but it has to apply it. It is what it is. Then it does suck 1, and then it does... maybe I'll put this formula last so it doesn't apply it that much. So it does suck, it reverses it, it does suck again, plus 2. Anyway, at some point it does suck 1, suck 1, and it gets to this suck 0 stuff, right? That's what it should get at. Yeah, it's kind of annoying that it applies that every time. Maybe if I move it at the end, it's not gonna apply that much. So let me just put these ones here. So now it's shorter, right? So it's converts this into suck 2, then into suck 1, then suck 0, then it does the a plus b, makes sense. Then it converts this one into suck 1, then it moves one suck from here to here. That's nice. Then it moves another suck, then it applies this formula, right? This is like the recursive case and this is the base case. So if you look at this thing like a function, you'd see that this is basically the base case. Let me just move this one, maybe just remove it, I don't think it matters. Yeah, so this is like the base case of the recursive call, and this is the recursive iteration, the recursive step. See, it's like if you have suck, then you move... oh, here maybe I have to do for all b just to be consistent, right? And in here, if you look at this stuff, you see that it's basically the base case, which is kind of cool. So it applies that, then suck, then it has suck 0 plus 1, so it gets suck 1, then it makes it a number, another number, and so on until it gets to 5. So that's why I say that now it would be important to have the natural numbers, this stuff to be defined somehow internally, so that we can do addition between any kind of number. So evaluate 1 plus 2, maybe, I don't know, is it gonna be 4? And it gets it to 4. That's really cool. I'm really happy with the results. Actually, it's kind of cool. So yeah, maybe let's try next time to do the set of natural numbers, and we'll see in the next one. So see you.